Hey, okay, welcome to another common support video. This one is on writing proportional relationships, writing proportions. Let's get into it. Boop. All right, so it says here, 3 folders cost $2.91. So there's lots of ways to set up a proportion, as long as you're understanding the ratios involved. So the way that I would normally set this up is price per folder. So price is on top and folders on bottom. That's the way that I would normally set the ratio up. So if it was me, I would do 2.91 all over 3. And that gives me my proportion here, the price for every folder, basically. If I just divide top and bottom by 3, I get my unit rate. So I would start there. And so the way that I would set this up is it says, which equation would help determine the cost of 2 folders? Well, then I would keep folders on bottom, and I would have the price on top, the unknown price. So that's the way I would set this up. So I would first look to see if they have the way I would naturally set it up. And so do they have 2.91 over 3 is equal to x over 2? And I see 2.91 over 3 is equal to 2 over x, but that's not the same. So this is a little bit of a problem, right? So I'm wanting the dollars to line up, so 2.91 lining up with the x, and the folders to line up, and the 3 lining up with the 2. And I want the 2.91 to relate to the 3, and I want the x to relate to the 2. So maybe they flipped it. Maybe they did it the other way around, folders on top and dollars on bottom. So if it was folders on top and dollars on bottom, then what would it look like? It would look exactly the same, except that it would be 3 folders for every $2.91 is equal to how much it costs for every, whatever, 2 folders. So this would be another option, right? You just flip everything top to bottom, basically, right? And if you did that, do we see that answer here? So 3 over 2.91, 3 over 2.91. I do see that there, but then it should be 2 over x. That's not going to work for C. But look, here's B. 3 over 2.91 equals 2 over x. This one matches, so I'm going to say B is good. So I like it. All right, cool. So you really just want to kind of play with it and see if they did it a different way or then you would do it, and just make sure the ratios stay the same. All right, so for the next one here, we've got a situation where we've got rubber stamps and cost. So I would normally do the cost per stamp. So I would normally do the cost on top and the number of stamps on bottom. That's kind of how I would normally do it. So let's set that up that way and see if it matches anything they have here. So if we're setting it up here, right, I would put the stamps on top, and I would put, sorry, not the stamps on top. I would put the dollars on top, the price per stamp, right? And the stamps on bottom. So my unit rate would be price per stamp, okay? So this is 10 rubber stamps for $10.30. So it would be 10.3 over 10. And it says, which equation would help determine the cost of 2 rubber stamps? Okay, so that would be, the stamps are now 2, and the cost is what? That's not unknown. So I would normally set it up just like that, right? So 10.3 over 10 is the same as x over 2. And I'm looking at it, I see 10.3 over 10, and I see 2 over x. That's not going to work for me. I see no other relationship where there's 10.3 over 10. I do see the inverse of it where they flipped it top to bottom, right? So that would be something where if we flipped it, it would look like this. You'd have the stamps on top and the dollars on bottom. So it would be 10.3 on the bottom and 10 on the top. And the stamps now changed to 2. What would the dollar amount be? Okay. So this is the other way you could think about that relationship if you just did stamps on top and dollars on bottom. So let's see if they have that one. They've got 10 over 10.3. That's good. But then they have x over 2, and it should be 2 over x if that's the situation. I don't see any other situation that would work here. So A doesn't work and B doesn't work. So looking at this one, this is a different arrangement. So now, okay, so if these first 2 arrangements don't work, then you got to try something different. And so what I think that the next thing to try would basically be the dollars to dollars and stamps to stamps, basically. So now you're thinking about the relationship in the stamps on the left and the relationship in the dollars on the right, okay? So the ratios are now split this way, where you've got the stamps ratio. This is a really ugly way of writing stamps, isn't it? So I'm going to write stamps over here. There we go. So you got the stamps ratio on the left, you got the dollar ratio on the bottom. Now the key here is that you've got to make sure that you relate the stamps to their appropriate cost. Okay, so In this case, we can see that rubber stamps cost $10.30. So 10 rubber stamps cost $10.30. So you just want to make sure that the 10 stamps aligns with the $10.30 and that the 2 stamps aligns with the X. So you could think of it like this. That would work fine. Or you could flip it and it would also work fine. So you could do 2 over 10 as long as you had the X with the 2 and the 10.3 with the 10. So all of these would work as an idea of stamps comparison on the left and dollars on the right. And it could work either way, where you have the dollars on the right, on the left hand side, and then the stamps on the right. It doesn't make a difference as long as the ratios and relationships are staying the same. So let's see if they have any of these categories as an answer here. So we already eliminated those two. Let's see if we can get this one here. So this would be that 2 stamps relates to $10.30. That's not right. The 2 stamps relates to the unknown dollar amount. Okay. And the $10. This is also weird, right? This one has the 2 stamps on top of $10.30 is equal to X money over 10. So that doesn't look good either. I don't like any of these. I don't think any of these are good. I think these are the relationships you'd want to have. You could flip these left and right, but you still have these relationships, right? The 10.3 needs to correspond to the 10, and the X corresponds to the 2. So I don't think any of these are good. All right, next one. Let's try again. So over here, we're going to kind of I'll erase this stuff here. And make more room. Let's get rid of this stuff. Boop, 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 boop. All right, awesome. Get rid of this, get rid of this, get rid of this, get rid of this. Okay, so it says which equation would help determine the cost of 5 watermelons, given that 7 watermelons cost $8.96. So first thing you would do is you would say, I would say price per watermelon is my normal natural go-to. So that means price goes on top and watermelon goes on bottom. And so you'd have 7 watermelons cost you $8.96. If you divide top and bottom by 7, you get the unit price or the cost per watermelon. And so the cost of 5 watermelons, we're going to change the 7 to a 5. We're still talking about watermelons on bottom and cost on top. And the cost of that would be unknown. That's the way I would initially set it up, right? So that's what I would be looking for. So 8.96 over 7 is equal to x over 5. 8.96 over 7 is equal to x over 5. Yay! That's perfect. It doesn't matter which one's on the left or right because it's just an equal sign. So it's the same exact thing either way. So I'm going to go that one. We're done. Okay, the last one we got is rubber stamps to dollars. So in rubber stamps to dollars, we're going to set this up with dollars on top and rubber stamps on bottom. And so I'm going to set that up that way. And so we've got the stamps on top. We got the dollars on bottom. Hello, my lovelies. Can I have some space? Because I'm making a video.
Trying.
Hey, Bobby, I'm making a video. Okay. So you can use stamps on top, dollars on bottom, or dollars on top, stamps on bottom. It really doesn't matter. And all right, sorry guys, my wife and daughter came in, and I had to give it a little more time here. So, anyways, stamps on top. Either way, you set this up. So this is 5 rubber stamps for $9.70. So you can do it like either like this. You can say we have 5 stamps for $9.70, or we can say we have $9.70 for 5 stamps. It doesn't matter which way you set it up as long as you're consistent. Okay. And so then if you set up the top way here, you would say that the cost for 11 rubber stamps, so now the stamps changes to 11, what would the cost be? And if you set up this bottom way with the number dollar on top and the stamps on bottom, you would just change the stamps to 11 and the dollars on top here. So these are the 2 ways I'd set it up. I would say that the one that I naturally would use would be this one actually, because I want the dollars per stamp, I want the price per stamp as my ratio when I do my equation. And it's always output over input, right? This per that. So I would look for these 2 as my answers first and see if they have them. So let's see if they have any of these answers. I'm going to look at the one I like first. 9.7 over 5 equal to x over 11. 9.7 over 5. They don't have that one. So they don't have the 9.7 over 5. Maybe they have 5 over 9.7. Okay, they have 5 over 9.7, but that should be where it's going to be equal to 5 over 9.7 is equal to 11 over x. So 5 over 9.7 corresponding to the 5 should be the 11. So this is wrong. All right, so looking at a little more carefully, this one doesn't work This one over here, 11 over 9.7, that one doesn't make any sense at all, because you're not, the 11 isn't $9.70. The 5 costs $9.70. So this one doesn't make any sense. So let's think about other things that we could set up appropriately. It doesn't look like they have either of these two original scenarios that I set up. So then the next thing to look at is the relationship between the stamps on the left and the dollars on the right, or vice versa. And so then in this situation, you have something like this, where you've got the stamps over here and the dollars over here. And so we know that 5 stamps is to $9.70, as 11 stamps is to an unknown. That would be the way you'd set that up. And remember, in that scenario, it can be either way, right? So you can flip it top to bottom as long as you have the corresponding parts where they belong. So you can say 11 is to 5 as x is to 9.7. That would also be a perfectly appropriate way to set that up. So do they have any of these options for us? So I see 5/11ths, that's encouraging, but 5/11 should be equal to 9.7 over x, and it's not. Let's flip that. This is wrong. I see 11 over 5, that's encouraging, as long as it's x over 9.7. And 11 over 5 is not 9.7 over x, it should be x over 9.7. So this is wrong. So remember, the parts have to correspond to one number. If they don't, here, this is all bad. So that's how you do it. Okay, that's it. Let me stop the video recording here and see if I can end this one.